Hi, my name is James Dean Vogel, and this is Between Two Ferrules. Today's guest is Richard Hall. Richard is the head of business development for RATTIINOX S.R.L, an Italian manufacturer of CIP-friendly aseptic valves, connectors, and pulpsit filters. He's a member of the ASTM and also a member of ASME BPE. He has worked with the ISPE Europe, Biotech, SIG, PDA, A3P, and other technical groups in our alphabet soup of organizations that we have. So he is a self-described subject matter enthusiast of clean by design and is helping to change the industry. Let's welcome Richard Hall. Welcome, Richard.
Hi, Jim. Good to meet you.
Welcome to the Bioprocess Institute.
Thank you very much.
Well, it's great to have you here at the Bioprocess Institute. So, I know you're a member, an active member of ASTM, and you've just been named head of the E5511 committee, right? What's the name of that group?
That's right. E5511 is part of the reorganization of ASTM. Should I mention a little bit what ASTM is first?
Sure, that's fine. Yeah.
ASTM is an organization that writes consensus standards, and I think they have about 15,000 standards in total.
And it is an international standard, right? It's not just the United States.
ASTM was originally the American Society
Testing Materials.
Testing and Materials, I think. Yeah. But is now in much more international, I would say.
Yep.
And the standards are recognised in many different countries. And within ASTM, there is a committee which is E55. Which produces standards that are for the pharmaceutical and the biopharmaceutical industry. E55, up until 2 or 3 months ago, was organised into two main subcommittees, one for pharmaceutical and one for biopharmaceutical applications. Recently, there has been a change of chair of E55. And there is now a reorganisation of those subcommittees in a different way, because obviously a lot of applications are common to pharmaceutical and biopharmaceutical, cleaning for instance.
Yep.
And also with the much more extended use today of single use, which I think maybe only 10 years ago hardly existed.
Yep.
It was obvious that a subcommittee for single use was necessary, was required. So the decision was taken to split not by industry, but by in other methods. And now, for the future, there are 6 subcommittees. 07, so E55.07 is single use. 06 is microbial contamination control. 11, which I'm heading up, is process design. E55.12 applications, and E55.13 process controls. To be honest, the scope of those is still under discussion.
Okay.
And I have to say, I'm not completely clear. We're still discussing in monthly meetings exactly the scope of each of those. And when the scope is fixed, we can then transfer the existing standards that are either being written, they are work items, so they're not a standard yet, or the rewriting of existing standards that need to be modernized.
Yep.
That each of those can find its home in one of those subcommittees. And one thing I should point out is that any standard within ASTM that is not renovated after a period of, I think it's 6 or 7 years, dies.
Right, but then there's either a biennial or a periodic review that then they're re-upped, right?
If there's a decision, first of all, on whether this standard has a place in the world anymore.
Okay.
Because maybe some standard has already achieved what it set out to do and the industry now goes that way.
Okay.
Or the standard has been superseded by, I don't know, a guidance from another organization that covers it more effectively. First of all, there's a decision, does this standard deserve to continue existing?
Okay. When do you think that this reorg will be complete or at least in full swing? Another 6 months? A year?
No, I think within 3 months.
Okay, good. So then
I
sometime
mean,
in 2023,
we've
this
got a
should be-
Oh, definitely,
Yeah,
yes.
okay.
I would say probably by September. The interesting part obviously will be moving or asking that people move to different subcommittees depending on their interests.
Yep. And
Because we can't shift people from one subcommittee to another. People have to, that's something they decide as a member of ASTM where their interest is.
So why don't you tell us a little bit about your company, RATTIINOX?
Not my company, but I work for them.
The company that you work for, okay.
I would laugh. RATTIINOX is a manufacturer of aseptic valves based on a radial diaphragm. For anybody who doesn't know, that's what a radial diaphragm looks like. That sits on a seat and closes quite effectively. RATTIINOX historically manufactured lots of valves, mainly for the food industry in Italy, and were asked to start producing special bodies for a company called Novoseptic, who produced radial diaphragm valves. They still do. They also manufactured quite a lot of special bodies and welded them for a weir type valve manufacturer. And one day, the boss of the process division of Novoseptic met the owner of RATTIINOX, and together they decided to launch what they like to call, or sorry, we like to call, the third generation of radial diaphragm valves. The first generation that you'll know is originally the Steridos or Asepco type. Novoseptic we would call the second generation,
Yep.
which got rid of some of the issues that the first generation had that
Yep.
I'm sure you know something about. And RATTIINOX identified that the second generation of valves, Novoseptic valves, were designed long before the PTFE diaphragm became really interesting for our industry.
Okay.
It's a material that we all know has some unique properties. It's pretty inert to virtually anything that we use in our industry, biopharma and also pharma. It's not affected by cleaning chemicals. It's not affected by extremely high temperatures. We have one application that's running at 200 degrees C currently. The real advantage, I think, for RATTIINOX is that they designed first the diaphragm and then the valve, because PTFE is, I'd say, well known for having some defects. One of those is cold flow. So it is absolutely critical in this area here to close the valve effectively between the body and the actuator that fits here. I don't know if you can hand me an actuator. That one there, that'll do. Closing that is absolutely critical in the design of a valve like this. This fits just with a ball into a slot on the actuator shaft, into the body, and is clamped by a ring that is treated with an anti-friction process that I can't name and that doesn't flake off. It's a heat treatment process. It's high in carbon and gives a very, very low friction on a thread that is a very very fine thread.
Yep.
You'll see on the Novoseptic, for instance, that's 2 millimeters. This is a 1 millimeter thread, and that allows you to apply sufficient torque, and we supply C-spanners to apply that torque. And the torque levels are really quite high, and we're very strict that those are applied, because if you don't apply those, then you will have leakage issues.
Okay.
That is how our valve basically functions and how we guarantee no leakage here. In terms of the designs, I'd say my boss is kind of a perfectionist. Walter Ratti is a perfectionist, and this is machined and mechanically polished. This is not a special component.
It looks like it could be on the exterior there.
It looks as if it might be electropolished, but it's not.
Okay.
He machines on extraordinary Japanese machines to 0.4 RA. Sorry, I'm not sure what that is in American.
Okay, but in millimeter or meters,
It's
0.4 RA.
I think it's 15 RA for you.
Okay.
Yeah.
Still quite good. Quite good.
It's I mean pretty much the equivalent of FSF 6, I think, but at 6 is electropolished. In fact, we're not so keen on electropolishing, and maybe that's a subject for a more technical
I think
discussion.
that would be another time.
The obsession in RATTIINOX is cleanability, longevity, and making for an efficient cleaning process. And that means, not just cleaning process, I'd say a process in total. So whereas I'd say the industry has been obsessed for a long time, since maybe some disasters back in the early 90s with Bars laboratories and so on, the industry has been obsessed by regulatory pressure, which from my point of view up until quite recently has concentrated on safety and efficacy and not on efficiency. And when I say efficiency, I mean operational efficiency. I mean doing things quickly. So everybody's been talking about whether it is cleanable rather than how quickly and robustly cleanable something is.
Well, you need a repeatable process. That's part
Absolutely.
of the validation process, is to ensure that happens. And then I think it's a question of maybe, the phrase that you've brought up is clean by design. If you design that in up front, as opposed to waiting till after you start up to worry about the cleaning, there might be the efficiencies that you talk about.
That's right. Our view, for instance, if we're looking at TACT, TACT, which is the typical time, action, chemicals and temperature, our view is that the A is down to design, not just of the system, but also of the components.
Yep.
And if you can effectively reach all areas within a body without any asymptotic areas around, for instance, a membrane in a weir type valve, which you and I discussed this. I think some of what you've said has surprised me.
Okay.
I'm keen to do more testing, and we'll be talking about testing with you. The obsession in RATTIINOX is not just for cleanability, but also for the efficiency of the entire process, which will be cleaning and then sterilization, for instance.
Mm-hmm.
So there is an obsession with drainability, for instance, and if I've only got two valves here, I've got a lot more in a box over there, but these are two diverting valves.
Multi-port valves, yeah.
So these are valves that have two diaphragms in, and you can either be in this case, for instance, this is for vertical mount, so that we've got the ports in the middle, and you could either choose between two inlets that could be, I don't know, steam and nitrogen,
Yep.
or you could have a single outlet which is being diverted to one place or another. And because this is vertical mount, we put the ports in the middle. This is one of we have 15 different variants of this in terms of ports. This will be one simply in one side and out the other, and we've got drainage to drain effectively from the body. We offset, or we call them tangential ports, that are offset so that you can drain from the bottom of the cavity of the body. So I'd say the three things we really concentrate on are cleanability, very long maintenance period. We have one application that's been running for 7 years with 450 valves, and they've yet to change a single diaphragm.
Wow.
And you can take them out, check their condition, and put them back in again. We have a very effective centering system so that they sit reliably in the same place. The other things are drainability that I've talked about, which obviously influences especially SIP times, heating up. If you can drain much more effectively, then you can reach SIP temperatures more quickly. We're firm believers in drying as well, especially in bioprocess. And that is one of the reasons that I got interested in clean by design, because I can see a lot of people talk about dirty hold times and clean hold times, but nobody talks about clean and dry hold times.
Okay.
And a lot of people don't define what dry is or how you're going to measure it.
Good. All right. So this is a very nice product. I think if someone was interested in this, who would they contact, or do you have reps in the States?
We've got a rep in rep called Pharmaceutic in the US, a guy by the name of John Swipes.
All right, and then obviously we can go to your website.
Or to myself, or you'll find our websites RATTIINOX.com.
Okay.
Or RATTIINOX.com, as you would say.
Okay, very good. So we've talked a little bit about clean by design. Can you define what that is and some of the things you're looking, because I know you're working on a standard in ASTM, and maybe, briefly just give us a thing of what that is, maybe the dilemma, or what you would call for others to kind of chime in on that.
Okay, I think my answer to that at different times in the last year or so has varied.
Okay.
Clean by design was really my idea was that I'd learned a little bit about TACT. In fact, I learned about TACT from Sanimatic.
Okay. So that's temperature, action, time, and chemicals. Right?
Exactly.
Right.
And I heard during COVID, I was able to go to lots of online meetings of lots of different organizations. I should be very clear here, I'm not an expert. I call myself a subject matter enthusiast. I'm a mechanical engineer. I've come from another industry that doesn't have the regulatory pressures that this industry has.
Yep. I think still have the technical requirements that are
we
needed.
Certainly have the technical requirements, but there was also a requirement to be efficient, because in the industry I came from, you needed to have a very good technical design. You needed to have excellent quality, especially if you're supplying to American customers, as I was, or even more, I'd say, specific in their requirements, Japanese companies with American factories.
Yep.
And the Japanese, as you know, are somewhat perfectionist and will have very specific requirements and ideas. What I saw from my history was that you need quality. You also need to have very reliable supply. And you also need to be truly competitive.
So you're working on the standard for clean by design. is there anything that you would want some of the people who are watching this video to contact you on or comment on or anything like that?
Well, there are quite. I'd say there are quite a few areas, either in Clean by Design or in ASTM generally,
Okay.
that I would suggest that. First of all, in Clean by Design, where it started was I'm a mechanical engineer, and I assumed all the problems are purely mechanical or physical. That if it doesn't clean, it's because you've got a dead leg, or it doesn't drain, or it doesn't whatever. Yeah. And what I've seen, and I realise there are exceptions, and I think we met one of them yesterday, where you worked before. A lot of the ideas that are now included in Clean by Design are more related to who is involved in writing a specification and what that specification should include, so that there are very clear ideas between the end user who is purchasing equipment and the industrial company that is producing that equipment.
Right.
And at the moment, I'd say in a lot of organisations seems to be a little bit hazy, and maybe there's a third party in between that's making maybe too many decisions for the user.
Well, I think in typical project management, right, there's roles and responsibilities. And then if it's a, let's say, less mature organization, they have to hire in contractors or people to do the work. And in my experience, there are times when the contractors try to take a one-size-fits-all approach, and that doesn't always work. It can work, but just to have effective project management, you need clear roles and responsibilities, and then obviously manage to all the normal things about what are your resources, what's the timing and schedule, and then what we're talking about here is the ultimate quality of the delivered product.
The quality, but also I don't want to go away from efficiency.
Yeah, well, and I think
because I think the obsession, and it's absolutely right, we're talking about things that we inject. That quality should not in any way be reduced by improving efficiency. When I'm talking about efficiency, I'm talking about doing it quicker and more robustly.
right, and I think
So I think that is conducive to higher quality.
and I think you and I've had this discussion over the last day or so that the robustness of the process and the demonstration that one is in control of their process is the regulatory requirement. Has always been that. The unfortunate thing is maybe people aren't as robust of the cleaning or other ancillary processes as they are as where they're processing cells or purifying a protein.
For sure, what you just talked about is much more sexy for a young engineer.
Exactly.
Than cleaning, and that's where in the industry I come from, we were obsessed with the non-value added processes, which cleaning is.
Yep.
I mean, if you don't do it, then you don't have a product.
Right.
But if you do it, it is non-value added.
Yep.
It's a necessary non-value added process.
Well, and it's one of the things why single use has become so popular, because you kind of eliminate it, right? Totally.
Well,
which brings other aspects into this.
But I think there's another thing which I saw some slides of yours at the ASME BPE meeting in Puerto Rico in January. Some slides of yours that Milena McFeeters, who's now the new chair of ASME BPE.
She formerly worked for us.
Yes. Jim taught her a lot.
No, she taught herself. Yeah, but she did work here for a while.
Right.
Great lady.
But the slides I'm referring to were showing another thing, which is that in single use, the supplier of the equipment, well, for me, the plastic bag with
Yeah.
things on,
Yep.
is taking some responsibility for risk management or quality of that product, sterility of that product,
Yep.
etc., which is radically different from at least my perception of the, some people call them dinosaur stainless steel world, where the responsibility for cleaning and sterility seems to me to fall squarely with the customer.
Right.
And that for me, it's a shame maybe that a lot of people, I feel, have maybe used regulatory pressure as an excuse for not evolving stainless steel systems in response to the competition, the threat, if you like to say it that way,
Of single use?
of single use.
Could be. Could be. I think that would be a great topic for another one of these, actually. And we could talk about
Sorry,
the threat,
I can be
threat of single use to multi-use.
Well, no, I think there is an obvious, undisputed place for single use, but I don't think it's in production, and I don't even think it's in a pilot stage.
Okay, again, I think
but
we're going to have to come back to that one. That's a loaded topic. Before we close, I know you did a fair amount of traveling when you were young in the United States, and you traveled quite extensively. Maybe you could share with us.
Extensively, no. I did this coast.
All right, so on this coast you traveled, right? Maybe you could share with us one of the special places you visited during that time that you could give us a comment of one of the
Well,
places.
I was traveling quite low cost. I was hitchhiking.
Yep.
I had a tent with me, and I think I was only in the States for about a month. And I stuck to this coast. My idea was to go further, but I ended up making some quite good friends. I remember specifically Fire Island,
Yep.
which is off Long Island.
Yep. And you had some good food there. And
I cut myself open. I still bear the scars of opening oysters that I don't know how you call it, with a
shucking.
rake thing.
Oh no, well you rake them to get them in, and then
I'm
you
not
shuck
sure
them.
it was strictly legal doing it.
Okay. I think the
I
statute of
remember that.
limitations may have worn out by then.
Yeah.
So.
And I remember very, very fondly the No Name restaurant in Boston,
Okay.
which is actually, I'd say, is quite similar in many ways to the place you took me last night.
Yep, the Bonneview here in Rhode Island. So definitely we met some characters there. Well, it's been an enjoyable discussion, and I wish you well with the RATTIINOX. And again, if you have any interest in the ASTM, we'll have a message at the end of this for both RATTIINOX and ASTM for you to get contact details. So again, thank you, Richard, for joining us here.
Thank you very much, Jim.
Between Two Ferrules. Thank you.
Thank you.